All right, guys, welcome aboard. We are going to have our lesson now about other angles and arcs with our circles. And we're going to be looking today at when the vertex is inside and when it is outside of the circle. First, let's warm up and let's take a look at some problems together, or this little problem together, reviewing some of our previous lessons. Find the measure of the indicated angle or arc. So it's asking for the measure of angle P, I'm going to trace it, P, M, O. So this is the angle we're looking for right here, angle PMO. What type of angle is that first? M is my vertex, and it's at the center, so this is a central angle. And based on my rules I've learned, I know that that equals the captured arc. So the measure of angle PMO is going to be 68 degrees. Okay, now we're going to move to the next one. The measure of angle PNO. So this is PNO. All 3 points of the angle that define the angle are on the edge of the circle. By definition, that makes this an inscribed angle. And I know that it is equal to half of the arc that is captured. So when I think about, I start at P, I trace to N, O. From P to O, this is the arc that is captured by this angle. And it's going to be half of that 68 degrees. So this one right here is 34 degrees. Okay, continuing on, angle QPN. Let's trace it. QPN. All 3 of the points that define the angle are on the circle, so it's an inscribed angle. And it captures arc QN. So this one is my inscribed. So it's going to be half of the 118 degrees. So this one is going to be 59 degrees. And then angle QMN. QMN. This one is a central angle. The vertex of the angle is at the center of the circle. Remember, this is circle M right here. Because we name circles for the center point. So when I see that my vertice of my angle matches the name of my circle, I know it's a central angle and it's going to equal the degrees of the arc that it captures. So that one is 118 degrees. So QMN is 118 degrees. Now, based on these angles and arcs, I do want to put the central and the inscribed. We know that central equals the arc and inscribed is half the arc. One thing I do want to kind of mention, just as a little FYI, when I look at this, I look at Q, N, O, P. Notice that is what we call and it could be in any order. I could do NOPQ or OPQN and just travel around. This is an inscribed polygon, specifically a quadrilateral, because all of the vertices of the figure are on the circle. Some things that we know about this is that the opposite angles are supplementary. And that all 4 angles add up to 360 degrees. In other words, this entire angle P, this entire angle Q, the entire angle N, the O and the Q, all of those entire angles would add up to 360 degrees. All right, so we're going to be looking at secant and tangent angles, and we're going to need to determine whether the vertex is inside or outside the circle. We're going to look at some different formulas together to help us solve for angles and arcs in these situations. First of all, vertex is inside the circle, but not at the center, okay? So we want to identify our situation first. Always look at identify. In other words, you're asking yourself, where is the vertex? And here, okay, this one is, it's in the circle, but it is not at the center, okay? It's also not at the edge. I'm just going to make little notes of that. So we can't use any of our previous formulas. We can't use that it is equal to the arc or equal to half the arc. These would be, angles that are made by maybe a chord. Remember, a chord has its edges on the circle. Two chords. Or, if they extended through the circle. Ooh, that's a terrible drawing, but I'm trying to trace this. That would be two secants. So I would have a secant and a secant. Or the chord and chord. Those are two possible situations. So we have a formula that deals with these. Now what this formula means is you have to look at the arcs that are captured by the angles that are created. So if I'm looking at this angle right here, I'm just get a different color. This angle is the one they're notating. That means I would take the measure of this arc and go across it again, and this arc, remember this vertical angle right here is congruent to this one, so I would take the two arcs from the congruent vertical angles, add them together, and then divide by 2. So remember, we've got vertical angles, and they are congruent, remember that. Don't forget, we also have some other situations, linear pairs. They're supplementary, so they add up to 180 degrees. So if I knew this angle measure, I could know this angle measure because that's a linear pair. And then let's also just not forget that our entire circle has 360 degrees. Okay, so now let's take a look at this example. Don't forget, all circles have 360 degrees. Let's go through a couple of quick examples. So I need to find this arc. Now I have interior angles made by two chords. So first of all, I need to think about, if I take the 180 degrees for this linear pair here, or I've got a linear pair with this 88, and I'm doing it with this one because I've got this arc of 84, I know that this angle is now 92 degrees. My formula is that this arc plus this arc divided by 2 will equal the 92 degrees. Okay, so now I'm just going to set it up. This is my given arc plus an arc divided by 2 equals my angle measure. Arc plus arc divided by 2 equals the angle measure. And then I will multiply by 2 on both sides to clear my fraction. Subtract 84 from both sides, and I find out x equals 100. Let's look at another example quickly. This one I'm thinking, okay, they want me to find this angle. I need this arc here plus this arc. Okay, those two arcs are the ones I would add together and divide by 2, so I need this one. Well, remember, all circles have 360 degrees. So if I take 360 degrees and I subtract the 93, the 45, and the 89, it's going to tell me how much this arc is. So I take those out, and I find out that's 133 degrees for that arc. Now I can just use my formula of arc plus arc divided by 2 equals my angle measure. Multiply by 2 on both sides. And I end up with 2x equals, what's 133 plus 45 is 178. And I'm going to divide by 2 and divide by 2. Okay, so now let's take a look at a couple examples here. We're probably not going to finish these in this video. We'll go to another one. First of all, I want to let you know this problem right here is right there. So let's just look at these two. Sometimes you have to find the angle. So let's think about this. This is what I'm looking for. Remember, my angle measure equals the captured arc and the one that's across from it. Arc plus arc divided by 2. So I'd multiply by 2 on both sides. What is 124 plus 48 is 172. Divide by 2 on both sides. And I get x equals 86. Let's try this one more right here. I'm looking for this angle measure. So I'm going to have my arc plus arc divided by 2 equals my angle measure. Multiply by 2 on both sides. And I end up with 240 equals 2x. Divide by 2. And I have 120 degrees. That equals the angle measure x. 86 degrees. And then sometimes we have to find the arc. Here I'm given the angle measure for this one, but I'm here and I'm looking for this arc. Remember, my linear pair postulate allows me to know this is 70 degrees. So I know that the given arc plus the arc divided by 2 equals 70. Then I have 45 plus x equals 140. Subtract my 45 from both sides, and I have that x equals 95 degrees. Looking for this one right here, I know that that arc plus the 78 degree arc divided by 2 equals my 123. I get x plus 78 equals 246 when I multiply by 2. Subtract my 78 from both sides, and x equals 168 degrees. That is the measure of the degree of curvature of that arc. All right, guys, I'm going to stop it here, and we'll pick up in the next video, and we'll work some more examples with each other.